How's it going, guys? Let us know if you can hear us, if we sound all right. We have Pablosdog. He makes some awesome observations in the chat. The Plain Truth.
Oh, it's just now. Maybe it's delayed.
And then we have Brian Leak or Leaky in the... Is that Leak? Yeah. In the chat. Can they hear us all right?
I think so.
We can hear. All right. Awesome, guys. Thanks for joining us. We're a little bit more prepared this time. Shout out to Founded Earth Brothers. They suggested using StreamYard, and that's what we're going through this time. So I think we'll have a little bit better of a show for you. But yeah, I guess we'll go ahead and get started. We just wanted to kind of introduce ourselves and talk about what got us looking into flat Earth in the first place, and also talk about some of our observations and what we have planned with those.
And answer some questions.
Yeah, for sure.
Anything we have on our channel so far. Go over, I think you want to go over some clips and share some observations, since we'll be trying out the screen share. So anytime maybe something doesn't work out, just bear with us while we figure out our technical capabilities. And I maybe holler in the chat if there's something we need to fix, and we will figure it out.
Yep.
So yeah.
But yeah, so my name is Sean, and I started the Skyfree channel, like I said, in 2018, and we'll get into more details about that. But
I'm Casey. I do the narrating and some editing, and am kind of starting some stuff on the summer free side, do some blogging, and maybe I'll make a summer free channel and kind of expand some stuff there too. So every once in a while you'll see a video where something's shared, but I haven't really been keeping up with it too much. But hopefully with the new year, I'm gonna try to bring summer free to life a little bit more.
Yeah, we're definitely going to focus a little more on some the summer free channel and some of that content. BMLSB, just got to say, one of my favorite channels. He has incredible observations. Welcome.
Yeah, maybe we'll kind of chill for a couple minutes, let anybody come into the chat.
Yeah,
that
I think
wants to join.
For sure. Just let a few more people come in, and then we'll just get started on how we stumbled upon flat Earth and all of that.
Why we're still looking into it, still doing things a few years later. Obviously weren't satisfied with what was there.
Mm-hmm. And yeah, we're actually going to talk a little bit about some of BMLSB's observations, some of the Plain Truth observations. So, like Pablosdog, like I said, he does some awesome observations. We'll go into some of that.
So in the chat, share the show? Does that mean for us? Is there somewhere else we need to share it?
I think he's talking to people in the chat, I believe, to share the show.
Okay. I'm going to make myself sound real silly, probably sometimes, about YouTube. How long ago was it that we came to flat Earth?
All right, we'll just get started. That's basically the first question we were going to answer. So we'll go ahead and get started. In the summer of 2015, we first heard about flat Earth, and like most people, didn't really take it too seriously. Kind of thought it was a joke. I remember just thinking it was probably one of the dumbest things I'd ever heard, because I believe we've all kind of been programmed to think that way. And so I just kind of wrote it off for a few months, and then it was February of 2016. And here, I'll go ahead and start screen sharing. February of 2016, I saw this scene from Comedy Central of astrophysicist Neil deGrasse Tyson, who I had always looked up to. I watched Cosmos, and it was one of my favorite shows growing up and everything. And, I was just kind of shocked at how he acted. He didn't really present any evidence.
Because he went on there to kind of dog on B.O.B., the rapper, who had made either an Instagram post or a tweet or something comparing some objects in the background and their distances.
that was a different
that
time.
Wasn't
Yeah,
that started
that was a different time. This was just they didn't address that in this scene, but
wasn't it about this was about B.O.B.
Yes, this is about B.O.B., the rapper. And so I just thought it was odd that you have an astrophysicist going on to onto Comedy Central and really just mocking and belittling a rapper for his beliefs. And it just seemed like an odd thing. And the epic the mic drop scene, all of that. Right about then, when the mic dropped for that's when I personally was like, all right, I'm gonna look into flat Earth. I'm gonna start taking it a little more seriously.
You were like, okay, now you've got my attention.
Yeah.
Like, why?
Right.
Why the silliness, the mocking, just especially from a scientific community.
Right. He's supposed to represent one of the world's leading astrophysicists. He should be representing science, and he's out there mocking people for their beliefs. So right then I was like, okay, I'm looking into flat Earth. I'm going to take it a little more seriously. And one of the first observations that really piqued my interest, let me see if I have it right here. And unfortunately, I had all these kind of at the exact time in the video I wanted, but they're all refreshing now. So give it just a second.
Too many tabs.
Yeah. But it was actually a Phuket Words observation over the bridge where he sees the biker going over, and it just disappears into the vanishing point and everything. And that's what
I remember seeing that, because I remember us talking about that shot. Just, it was interesting. And then but really it wasn't even until later or just like kind of became relevant again later, after we started making our observations and videos.
Yep.
Then started kind of focusing on refraction and miraging, stuff like that,
yeah, and
in that video.
And this is not, it's taking its sweet time.
Wow.
Yeah, sorry about that. There we go, finally. And this is actually a video from Taboo Conspiracy, who's another great channel. So let me, and he's comparing kind of this Soundly footage of Lake Pontchartrain and the power lines with Phuket's footage. And yeah, so this is what kind of started it. I had seen this observation. I was like, wow, that's pretty interesting. I started wondering if it would scale, if this effect was happening just kind of randomly, or if it was happening at a rate that kind of matches the alleged curvature of the Earth. And Taboo does a great job here, kind of showing a side-by-side comparison of Soundly's footage and that bridge observation by Phuket. And there were other channels, which I think we talked about a little bit last night on our test out stream. Good Times for All. He had some observations in a warehouse that were pretty awesome and eye-opening. But yeah, so this is always awesome footage. You can just see the biker as he sails away. And the thing about this is, if Phuket did these observations a bunch, if there was a time when there wasn't much of a temperature gradient, all the air layers were about the same temperature, he would just see across the bridge and see the biker in full, at least until, the optical limitations were reached, basically. But yeah, so that's awesome observation there. And here's, I think this is Flat Earth Banjo, maybe. His footage on a different day at Lake Pontchartrain, and you can just see perspective. You can just see the lines moving away and basically going into the vanishing point. So it it varies day to day. That's something that becomes very clear to people who make and conduct their own observations.
Or do things often.
Yeah,
especially
repeated observations.
Realizing like, oh man, it's different all the time, and it doesn't take very much to make things very different. You have so many elements at play together. It's not just perspective, or it's not just temperature, it's not just distance.
Yeah, I mean, there are a lot of factors, so many different factors. All right, so we're gonna look at the chat here. B Flat, looking forward to having some conversations with B Flat. We've been emailing, and I think he has some really interesting points about the behavior of light, and we're looking forward to talking to him.
See the question, if light by definition.
Where was that at?
Right there.
Oh, okay.
If light by definition travels in a straight line, how would one actually?
Hey, that's a good question. Right. And that's the thing. B Flat has been talking about just the behavior of light and how we use the term bend, like light bending up, light bending down. And I think there's a good conversation to be had, whether that's even true or not, or if light actually just travels in straight lines and is more so displaced than bending. But Black Sheep Chronicles, welcome in.
Yeah, and B Flat says whenever we're ready, we can chat or something like that.
We're gonna have some open panels in the future. This time, I think we just want to kind of introduce and go over some observations and stuff, but we will have some open panels and we'll have some good discussions.
Especially once we decide which exact thing we use. If we'll stay with StreamYard or do Zoom or...
Yep. StreamYard's been pretty awesome so far. So, yeah, we'll see. So anyways, like I said, some of those observations that we saw really kind of piqued our interest. So we started making observations of our own. And I think you guys have seen, obviously, the land observations and the tennis court observations that we started with. And we started noticing that the scale or the rate that the objects were disappearing bottom up was such a similar rate to what we see on the large scale that we just wanted to keep going and seeing if it happened in various conditions and stuff. And sure enough, it did. Over water, over land, over ice. And one thing I want to point out about our observations is, because people will say a lot of times, like, they seem to contradict, because you guys say you're always seeing obstruction, but other flat earthers are claiming that, we see too far, and those two ideas seem to contradict. The reason why we see obstruction a lot is because we're picking, a lot of times we're picking like ideal weather conditions for that Globers would say you should go out and observe curvature in, like when there's not a steep temperature gradient, when all the air is pretty much the same temperature, there's no crazy temperature fluctuation. We're picking those conditions, and in those conditions, when Globers say are the best conditions to view and see the curvature, that's when we're seeing the obstruction on the small scale. And that's why we see it so consistently, because their curvature, in my opinion, is the inferior mirage that we witness so often. And it only takes, like I've said before, it only takes 1 degree to have some refraction occurring. 1 degree of temperature difference in the air layers, and you're going to have some refraction.
It's super delicate.
Yeah, it is. And Brian says usually obstruction at midday in Florida. And yeah, if you do a bunch of observations, you'll notice certain patterns, I guess, certain patterns within the observations, and you'll start.
Yeah, because sometimes you'll start predicting things like, the temperature or the forecast today is going to be blank. So I bet, if we went down to the lake or out in the garage, we might be able to see this or that. Or, maybe today we can catch that ever elusive looming, so.
Yeah. And we are trying some looming tests. With the garage test, a lot of times we have a warmer environment to begin with, and we're letting cold air in, and we get that sinking effect. And so we've had some people suggest trying it the opposite way around. And so we have done that a few times, but nothing really occurred. It might be because we need more temperature difference. We need it to be a little colder indoors and warmer outside or something. And we've also tried some garage tests recently where we let the garage get super cold. And then we place a slight obstruction in front of the objects that we've been using. And we turn our heat on, which is up near the ceiling. And so you have hot air rushing in over a cold environment. And we still haven't yet seen looming. So I think one conclusion we've come to is that it's far easier to witness sinking refraction than it is to witness looming.
Yeah, that happens way more often.
I mean, and with the slightest temperature difference. So, and
is that what we're always seeing, like all the time? Like we were talking about yesterday with Plain Truth, about you being in the car and driving down the road all the time, just looking over the dash and seeing, is that? And
that's an inferior mirage and or sinking. They're both pretty much one and the same. They're both from upward light refraction,
right? Which
causes sinking effect. Yeah. And so, I mean, you'll see that every day, just driving down the road. You'll see inferior mirages constantly. The Plain Truth says, Sky Free, what do you think looming would look like? That's a good question. I think looming works pretty much the way sinking does. And what happens with sinking, from what we've seen, is that, like, right as the effect's starting, you get this, if there's like awesome, Wide Awake's in. Good to see you, Wide Awake. We're going to have you on in the future. But back to Travis's question, if you get the right when you're getting your sinking effect, like in the at-home observations, before the mirage really sets in and becomes super obvious, a very subtle sinking effect happens. And so it looks like realistic looking curvature. What Globers will always say, there's no mirage and the boat still disappears bottom up at the horizon. It's curvature. Well, in our opinion, that's the slight sinking effect that occurs whenever there's very little temperature difference in the air layers. And so if there's a slight difference in temperature, you get that realistic looking curvature. But for looming, I would say, I haven't seen it yet, so it's hard to say, really.
Right? Like, would anybody actually know what it looks like? What's it supposed to look like? Like, what?
Any kind of superior mirage I've seen, a lot of times comes with pretty extreme distortion, and it's kind of being stretched upward. It's not, normally a clear looking view that you get a lot of times with so-called superior mirages, like the Chicago skyline across Lake Michigan or the Black Swan observations. It's normally more distorted, but we're going to keep testing and seeing if we can witness looming in our observations. And, and another thing is, even if we were to witness looming, that doesn't prove the sphere, because a lot of times in conditions when there's looming, so-called looming, like BMLSB, for instance, his observations, a lot of times the surface will actually appear concave in those observations. And so, as I was saying last night, in my opinion, that means it's all happening from flat. If you get the conditions for downward refraction, slight downward refraction, then the surface will appear concave. And if you get the conditions for upward refraction or sinking refraction, then the surface will appear convex. So yeah.
BMLSB said, I was going to type in.
Yeah, that'd be awesome. That'd be awesome, Bo. If you could send those my way. I want to do some, and actually I have some footage we're going to go over of yours here in just a bit, but I want to do some comparison videos soon. And
Sky Free, should I put the Sky Free email in the chat?
Oh yeah.
Or
yeah.
Does he already have it?
No, he doesn't. You can go ahead and put that in there. Yeah, we're going to put our email if anyone wants to email us any links or anything.
This
Sky Free Life 11. Okay. B Flat says, I'm ordering up a rectangular magnifying glass to study lensing effects. If you take a standard magnifying glass and rotate it out of the parallel, you get similar effects. That is awesome. Yeah, and B Flat just started up his channel. If you guys go check some of his work out, I think he'll be putting out more content, I believe. He has really interesting perspectives. Okay, so Black Sheep Chronicles says, which is easier, make a flat surface appear curved or a curved surface curving more? At Sky Free.
Right? It seems like...
Well, I would say that...
that's kind of what we were talking about yesterday, that it seems like, you know, if your starting point or just kind of the baseline is level, and it only takes a tiny bit of difference to make it either like, what is that, convex and then concave, convex and then concave, like it can easily pop from one or the other like a fisheye lens. But if you are going from concave to convex all the way,
you're doing it opposite. But yes,
did I do it opposite again? Okay, well, you know what I mean, like
for sure. And that's
to go from curved to the more extreme.
Yeah, absolutely. I think it makes more sense because a convex surface to appear concave, it seems like that would take a lot of refraction. But Black Sheep Chronicles is actually asking a curved surface appearing more curved. And actually, that's the thing about a convex surface, is that because sinking refraction is so common, if the Earth were to be a sphere, it would appear even more spherical than it actually is most of the time, based on what we've seen. So, even if they want to argue that the Earth has to be a ball, well, they should at least be questioning the radius, because sinking refraction occurs so often. It's so easy to observe. Anyone can go out and do these observations, and it's just not really accounted for much in their calculators and all their math. So yeah, I think a curved surface would appear more curved given our atmosphere and a standard temperature gradient. But all right, let's get back to this. We want to go over our recent Battleship observation and kind of just show how that scales a little bit. So this is at the end of the observation when the boat was a little bit over 900 feet away. Like we said in the video, it was really calm. Waves were pretty small. We were only about 2 inches above the surface. I'd say the waves were at most half inch or slightly more. So if we're scaling this, then our viewer height, let's just imagine 1 inch equal to 5 feet. So we're at 2 inches. That's like a viewer at 10 feet. Here we're getting the temperature. The water was about 55 degrees. The surface temperature was about 53 degrees. And the temperature around 5 feet or so was 50 degrees. So all of them were within 5 degrees. Here's the battleship we're going to use. And the scale, 6 inches is the tallest part of it. And so if we're imagining that in scale, that puts us at 30 feet. And so here it goes, it's selling out. And here it is around 300 feet from the viewer. You can see the hull still at this point for the most part. As it goes beyond 300 feet, you can still see the hull.
Oh, that's...
Okay, I'm going to pause it right around here. What's that?
That's a good idea.
What's that?
Get fishing rods and cast out the temperature gauge.
Ooh.
That's
a great idea.
We need to try, because that's, something we talked about and something you were trying to kind of deal with was, the temperatures where, as far in as we can put the
over the water.
Yeah, we need to get the temperature further in the water, not right at the shore.
Yeah, I like that. All right, so we'll pause that right here, and then I'm going to go to this advanced curve calculator. So for a viewer at 10 feet, their horizon would be about 3.8 miles away, right? So to scale, that's somewhere between 300 and, I don't know, 320 feet or something like that. Because 300 feet would be 3.4 miles to scale. So, that's somewhere around that range. And that's when we'll start to see the boat disappear bottom up over here, right around that range. This is probably approaching 400, getting between 350 feet or so, 400 feet. Anything in the chat, let us. So yeah, you can see the hole is starting to disappear. And another thing we want to point out is like Globers will say, oh, well, there's an obvious mirage there. And yeah, with the background, you can tell that there's an obvious mirage. That's easy to say, but out on an ocean or something where everything's in the band, in the atmospheric band that is mirroring.
Right. Imagine if that was blue ocean and blue sky.
Yeah, if this was just blue sky, you wouldn't be able to tell that this is a mirage happening so easily. And so you would say, oh, that's the boat going over the horizon. And I think by this point, I can't remember exactly where it's at. I think that's about 700 feet.
On the video.
That's about 700 feet right there. So here we go, 700 feet.
You can see it
stretching. And definitely some stretching going on, which happens all the time if you watch boats on large bodies of water. But you can see that earlier we showed with the scale here, we showed that what is it, 247? We showed that, sorry guys, one sec. That this little micro gun is about 3 inches above the surface, the water surface. And that's about where we're seeing the obstruction, somewhere around here. It's about between 2 and 3 inches or so. And if you go back to the curve calculator, now 700 feet to scale would be about 7.95 miles. And so let's look at what the curve calculator says. It says hidden 11.00, 11 feet basically. And 11 feet to scale would be just over 2 inches. And so let's go back to the observation. What I said was 247. Yeah, 247 or so. You can see that there's about 2 inches of apparent obstruction here due to the inferior mirage. And again, in my opinion, is the curvature of the Earth claimed by Globers or globe proponents,
right,
as we call them.
Like that's what you're seeing.
Yeah, that's what you're seeing. And again, yes, there's a lot of distortion here, but when there's less temperature difference, the sinking effect still occurs. It's just less obvious that there's refraction occurring. And so it's really convincing that you're seeing curvature because it's a pretty solid image, which we'll capture more of those days as we go on. We captured one of those days with our old camera, but it's just didn't have the optical capabilities that this camera has. So
right,
we'll improve on that and show you guys more clearly.
The next improvement will be to, now that the image is a lot more clear and nice, it'll be to make the smooth movements and transitions, so it's not like
the up and downs and stuff, so we can show
Witch Project.
Gaining altitude. You can see over the alleged curvature, the curvature of
I think it nice
an inferior mirage,
smooth. Still waiting on Travis to make the device. We need a little bitty one.
Yeah, we absolutely do. Any comments?
There's some good stuff in the chat. Wide Awake says, I can prove looking in a different direction, things can change drastically, which in my opinion is due to different temperature changes. Yeah,
absolutely. That's awesome, David. And we're going to go over some footage of yours too here in just a bit.
And temperatures in the Gulf changes in deeper waters in a different direction. So it's hard to get a proper temperature reading. Yeah. And speaking of temperature, another good idea about putting a thermostat on the boat directly and wirelessly.
Yeah. I like that.
That's what we do have some ideas for stuff for putting on the RC boats. We've done that a couple times. Adding a little flag or making the mast a little taller on one of the boats, and we want to add lights, do some things at night.
Lasers would be awesome.
Lasers. I liked the one we did one time where it was at night with the lights on the other side of the pond. We need to do that again.
Yeah, and even at night, you can get the infrared mirage that hides distant objects. All right, so yeah, let's keep going here. So we're going beyond 700 feet at this point. And
it's crazy how it like splits it in half, the image.
It does. And you can see some mirroring right below, right around there.
Oh, yeah. Black Sheep Chronicles says the foreshadowing effect of the light and energy transfer is what's causing the mirroring effect. It's compressed light optically at a critical angle below 48.8 degrees.
That's interesting.
Light and energy transfer.
Wide Awake says no curve needed. And exactly, that's what we've been saying ourselves. You know, all of this, I think, can be explained on small bodies of water where no curvature can be claimed, and therefore no curvature is needed.
And that's, again, kind of one of the things that, like, started our videos and our observations are like, okay, well, we know water is level, so no curvature there, especially on a small body of water. Like we said, like, you know, if we're within a certain distance, then according to the curve calculator, then any obstructions that we do see, those, it's not, you can't say it's from curvature. So let's just see what happens, you know, all of the same, you know, treating it like it's a large body of water, or, you know, what's happening on the big scale, what happens on a surface that we know has to be level.
Yep.
And surprise, the same thing happens.
Yeah, exactly. All right. And so at this point, it's a little beyond 900 feet, or around 900 feet. The opposite shore from where we were viewing was just over 1,000 feet, and we didn't quite get there. Let me go to about right somewhere around here.
Yep.
Okay.
And you could also, says you could also put a thermometer under the boat, waterproof, to read. And that's, yeah, we just need to up our game on thermometers.
All around, just data collection on temperature data is, I think, definitely something we'll be looking to do.
That'll be the next little improvement.
Yeah. All right. So here we're, like I said, we're around 900 feet, maybe a little bit more. And so 900 feet, real quick, let me see that to scale. So 900 feet, we're looking for inches. So 900 times 12, that gives us 10,800 inches. And again, we're doing 1 inch equal to 5 feet. So 10,800 times 5 gives us 54,000. And then we're going to divide that by 5280. And we're going to get 10.23 basically miles. So let me put that in 10. Sorry, it's a little high here. 23 miles from a 10-foot viewer height, viewing an object that is to scale 30 feet or 6 inches. And hidden would be about 27 feet. So 27 feet, that should be about 3 feet of visible boat left. And back to the observation. The very top, only the top inch or so of the boat, it is mirrored, it's stretched a little bit, but only the top inch, that top tower, which again, right here, only about an inch, maybe a little more, but that's it. So again, so closely matching to what the curvature calculator would suggest is curvature, but we know it's not. So I think what this definitely shows is that there's an alternative explanation. And I think so many people out there, you guys in the chat, just people in general who have been making observations over the years, have shown that there's definitely an alternative explanation to what's going on with
right. That shouldn't be the old saying, you know, about boats sailing out over the horizon, you know. That's obviously there's a few different reasons why you'd be seeing that. So, or just the one.
All right, so let's go back to the chat. Plain Truth asks,
Can you film to the opposite shore? Right. Yeah.
Yeah.
We need to do. We've done that a couple times. We haven't done that on this new lake yet.
We haven't. And this new lake is a little bit bigger, so we could even do, slightly further distances and everything. A lot of times we try to avoid going too far because then all of a sudden Globers will just claim it's curvature. They'll just say, oh, it's happening because of curvature. If we go out to basically from our viewer height of 2 inches, we were only going to go at most to 2,000 feet about, because at that distance, no curvature can be claimed. It would take about 2,600 feet to see any curvature, but we can always move up a little bit. We can go up to, 3, 4, 5 inches and view a little further, and no curvature will, be able to be claimed then. So we'll see what shoreline we can get on the opposite side and put some objects over there. And that actually segues nice into,
and drive the boat around over there and just kind of see what.
Yeah. Into the next thing we're going to do. I think this. Oh, is it?
Right. If we demonstrate the shoreline is there, then they can't make that claim.
Right. 1 second, guys.
Yeah, they dismiss everything viewed at low angles above water for a reason. It proves their curve calculator programs are garbage.
All right. But just to end on that, Travis, the Plain Truth, has some footage at Chesapeake Bay, and where he's viewing different objects over there. And at some point, we're going to try to maybe scale some of the observations he's done. And like we've said before, the Chicago skyline and all that. So look forward to those. But let me get on to Life is Short's observation, because a lot of times people will say, oh, it's the waves that are blocking the objects, which I'd say definitely not, because you can see the object when it's closer before it hits the mirage in full. And then as it sails away, it starts to sink because of the mirage. But anyways, this is footage from Life is Short, which you check. I'm sure you guys have all seen it. His videos are awesome. But
yeah, I love this one.
This one's great. So no waves at all. It's there's no mirage that is visible or anything. In my opinion, there's a very slight sinking effect happening, because unless there's 0 degrees again, you're not going to see the object in full. So, yeah, you can see here.
Can't claim curvature. Can't
no
claim
curvature.
waves.
This is 400 feet. The amount of the amount of curvature drop in 400 feet is basically nothing. It's like, I can't remember, a 20th of an inch or less. But yeah, let's get back to that. You can just see that debris on the opposite shore just gone. And then that also goes into some of BMLSB's observations, which are just awesome. He would go out and make a bunch of observations, and I believe, correct me if we're wrong here, Bo, but he made a ton of observations, and he would see this mirage, which we now know to be a mirage, day after day. But then, and this is our observations, we kind of see this same effect pretty often. But then he goes out and gets just the right conditions where now we're able to see further. We're allowed to see further. And boom. The horizon beyond the platform in full. And like we showed at the land of refraction observations, a lot of times in the evening, whenever the surface is not being, hit by the sun and warming up, and the temperatures start to kind of even out, you're able to see further. And so this is just an awesome observation right here. The black swan, as it's called, one of them. There's plenty of them from Bo and others. And so this is our observation. The objects are on the opposite shore around the same spot on a different day. and you can see it's kind of the same result. So there's obstruction. You can't see the objects in full, the oil rigs. And now same with ours. You can only see the tops of the boat and everything. And the reason why this water, it's not that the waves are so big. It's that we're looking down into the water to make this observation, because the mirage is happening and all this is stretching down. It's all sinking. The real objects, in my opinion, are up here. So this light, if we go on a day where we're allowed to see, would actually be up here and smaller. And this boat would be up here and smaller, and the lights and everything, they'd all be right here, but just much smaller. And we'd be looking up more instead of down into the water.
Yep.
And so here's Bo's observation again, BMLSB. And you can see the oil rigs and oil platforms in full. And we can see our objects in full.
See, now they're a lot shorter and squatter.
And they just seem further away. They're not as magnified as Wide Awake calls it a lot. Not as magnified.
Wide Awake says, wait till you see my new observation of the power plant I filmed. It's better than the last one I showed.
Awesome. We're looking forward to that. All right. So this is just showing some of the temperature data. Basically, Globers will say, when you have a temperature inversion, that is when you're seeing looming around the curvature of the Earth, light bending around the curve of the Earth. Well, in our observations, no curvature can be claimed. Those conditions, they describe a temperature inversion where it actually gets warmer as you leave the surface. Surface is cool, and then it gets warmer as you go up. Those conditions just allow us to see further normally. They can bend light down or refract light down, which makes the surface appear concave. And we'll show you some footage by Heath Carmody, great channel that sees the surface appear concave a lot just based on the conditions.
And even there, I can't get over how much different that last object on the left looks. Totally changes shape. It goes from being like a little teardrop shape to...
Yeah, look, just look how much bigger this is than... And the objects were in slightly different positions because I didn't memorize the exact positions, but they're all same distance.
That one on the end on the left
same
is
viewer
the
height.
Exact same object. And it just...
Yeah, the one on the left.
Yeah, that's the same one. And look at the difference in shape. It's crazy. It's like funhouse mirrors we kind of talked about before.
Yeah, it is. And so, it's just really similar types of condition stuff. And again, we can also see all the way across whenever the temperature difference is 0. Whenever we have no temperature difference, which even in our small local environments, it's rare to get 0 degrees of temperature difference in all the layers. A lot of times we're going to at least have a degree or 2, which will give us the mirage effect of some sort. So you need pretty prime conditions to see, further than normal. And that's what is going on here. And
that's something, just speaking of that kind of offshoot, but one of the things that was just such almost like the Neil deGrasse Tyson thing, but just such an irking, no, that's not, you don't have to be a flat earther to know that this statement or this thing that Bill Nye said a while back just was really silly. But when he was on, was it one of those big think
he's been on
and said something about if the earth were flat or whatever, why can't you see from what were the examples? Other Spain.
Bill Nye would say go to a seashore, go to the east coast of North America, and why can't I see Spain from the east coast of North America?
Yeah, Spain from the east coast.
4,000 miles away or something.
Why? Right. Why would the atmosphere, if flat or globe, you wouldn't be able to see that far anyway. That's just kind of a silly thing to say. But especially with just, with what we talk about, and
absolutely. That's a great point.
That just reminded me of that's once again, some of these old sayings and just kind of go to proofs. But sometimes flat earthers use similar proofs that shouldn't be, that
Right. There
that
are
you
straw
could.
mans kind of from each side, just not understanding the models, but it's a learning process. I think that's what we're all doing.
But of all, really, that was a silly Bill Nye thing that
Yeah, absolutely.
made it. That was early on to make us feel like okay. That's
a pretty pathetic argument.
That's not right.
No,
surely you guys have better stuff than that.
Right. No optics being addressed at all. A limitation of optics. So yeah, with the whole temperature inversion that we're talking about, basically that allows you to see further. Even on those days, though, you can still get bottom up obstruction because of compression. This was a day where, it seems like we can see all the way across the shoreline, but as the RC boat sails away, it just compresses more and more.
Why can't they see Spain? Because Portugal is in the way.
See, and so by the time it gets to the distance of about 600 feet, you can't really make out the bottom of it. And you can pretty much just see the sail on the boat. Has some footage from Wide Awake. Just kind of showing the mirroring. And look at that boat in the background. It's so much higher up. It's floating. It's on the water, though. But yeah, that was with our old camera. So yeah, let's keep going. The next thing I wanted to show was... Oh, this is going to take a minute. Bear with us. Oh, whoa. This is some footage that Wide Awake sent me. I'm just going to show the crazy effects that he got. He didn't get a lot of views on this video. And, it's some awesome footage, in my opinion. So this just shows, just the crazy changes you can get. And The Plain Truth has a lot of videos like this, too, with, I think it's Platform Gale, I believe. Just some or I think that's the name. But yeah, check this out. Yeah, this is wild, David. It's crazy. I had never seen this.
Oh, and is that mirrored? Or is that...
Yeah, would the audio work?
Look at the other one. You just have to go down through my videos and find them.
I'm not sure how that sounded, guys, but yeah, David talks about just all the mirroring and just the crazy different effects we get here.
And that's how you could see, like we were talking about earlier, there you can kind of see it, but when you have a blue ocean and blue ocean behind the boat and then sky meeting that, and it's all blue,
kind of all blends, and you can't really tell that there's any mirages going on. Obviously in this case you can, and you can just see this crazy distortion of these. Let me see if I can speed this up and kind of get a little time lapse of it.
Playback
speed, let's go times 1.5. Yeah, here in a second it gets really crazy, like double mirrors and just all kinds of stuff. But again, people go out and make these observations. This will happen. These effects will happen. And like The Plain Truth was saying the other night when we were talking to him on his show, a lot of times like mainstream refraction science will only talk about mirages in the desert in really hot times or in the Arctic. Like you need some crazy temperature to witness this. But if you go out and make observations, you see this all the time.
You see it everywhere. Now you can't unsee it. Speaking of which, I like this. Got the who's who of refraction in here. If only the guy who wrote the book on optics were here. Can't remember his name.
That's awesome. So yeah, just more crazy mirroring effects. And oh yeah, right there, it's coming.
I love how this explains that whole, the ship, the Flying Dutchman. Like, that makes sense now. Like, why, you know, some of those.
Yeah, a lot of times the Flying Dutchman's considered a superior mirage, and like the boat is supposed to be appearing where it actually is, but I think that could be interpreted a lot of different ways. It could just be where the boat actually is, and for some reason the boat isn't mirroring. It's seen solidly, but the water mirrors still, and so your horizon drops because of an inferior mirage of some sort, and makes it look like it's floating.
Well,
but look at that. Yeah, look at that separation there.
It looks like the Star Wars.
Wow. And you can see it down here. Wow. That's blowing my mind.
Yeah. That almost is. It's starting to look less like water and more like desert or something.
Yeah.
Like what the salt flats look like.
And salt flats, that's another good point to bring up. I think a really cool observation from Taboo Conspiracy, I believe, some years back over the Bonneville salt flats, where his wife drove in the car, and we're going to go over that in the future at some point.
We just need to go there too.
Yeah, seriously, do an observation of the salt flats ourselves.
Right, awesome.
So yeah, guys, Wide Awake, obviously you guys know, has just awesome observations, and go back and look through some of his stuff, guys. You'll find something new every time. And by the end of this, you'll actually, the distortion will kind of go away, and you'll see really where the boats are more likely at.
He says, watch it drop.
Mm-hmm.
Yeah, a land speeder.
Hey, we'll see you, Travis.
Yeah, that's a really neat video.
It is. Oh, yeah, there it goes.
And it's cool how you can see stuff going by in the foreground, too. Like, this is just way off.
Wow, see, there it goes. Now you're starting to see closer to where the boats actually are.
Oh, yeah, you can, like, see it.
Yeah, this one's still, it's just a little further away, I believe. And so looks like it's floating up here. There's all kinds of effects still going on way back there. Yeah. But as it winds down, still mirroring up there.
Yeah,
wow.
Look at that.
I mean, that's awesome, man.
Just
that is
like,
so cool.
That's how you get UFO sightings.
Right? Yeah.
I mean, really, though, like, joking, but there's so many things, such an unknown, like, area, or just not talked about, or really researched.
We all should have learned about refraction and all the possible effects in elementary or middle school whenever we could handle it.
I mean, it could be part of the, when you learn about even evaporation and water cycles, or weather and, physical science, obviously.
Absolutely. All right, and that'll lead into this other footage we want to show you by Heath Carmody, who we always recommend. His observations are somewhat similar to ours, where he's viewing from near the surface, but he's also getting time lapses of hours, and he's collecting footage from higher up as well a lot of times. So he's getting multiple views. I think one of the most underrated channels there is, only 422 subs. This video only got 79 views, and I think is just crazy, just awesome. So, and the thing about this day is there wasn't a whole bunch of temperature difference. Look at this up here. Look at some of the movement up here and just all around. But wow, look at that. But yeah, there wasn't a whole lot of temperature difference here. I don't remember the temperatures. He shows it at the end, but everything was within a few degrees, I believe. But yeah, you can just see. Oh, look at that!
Yeah.
It kind of reminds you of the what is that? The bay, Skunk Bay. The Skunk Bay footage kind of reminds you of that, where the horizon just moves everywhere.
I wonder if that's somehow what everybody's seeing. You know, those videos that got shared quite a bit the last year or two, like people zooming in on the moon and it looks like this wave goes through it, or like it's a loading.
It could be.
Maybe it's
just in
something
our local
like this.
our local
somehow.
atmosphere.
Yep. Maybe you're seeing through. That looks crazy.
Oh yeah, the whole thing.
Is that a bird or a boat?
I don't know. I think it's hard to say. But yeah, guys. So not a lot of temperature difference. Crazy movement throughout. Awesome observation by Heath Carmody. Go check out his channel and sub if you aren't already, guys. Does some awesome work.
And the time lapses, like sometimes on ours too, even a smaller body of water than this, but it's really in the time lapses, or even in the garage, just the garage. When you show me the footage and you speed it up and it looks like that, and then you can really see how much is changing, and just thinking about how like that's what's happening around you all the time with temperature fluctuations, and you don't even realize it. Like how much it jumps like that.
Yeah. And then so yeah, Heath, I mean, just great stuff, guys. Like this is where it's at. He gets the temperature readings. I think they're all around, that looks like 60 some degrees Fahrenheit. And the water temperature was right around there too. So not a lot of temperature variation, and yet crazy refraction, as titled here.
Yeah, Wide Awake says he's planning on doing time lapses too of the power plant.
Awesome. Yeah, that'll be great. Very useful.
I love watching the time lapses.
Yeah, time lapse is pretty telling. I mean, it helps a lot. All right.
Because it's tough. Sometimes it's funny how when we did the land of refraction experiments and we were looking at, even some distant mountains that would change in size throughout the day and throughout the different, fluctuations. And it's stuff that we knew, or we had talked about a couple years before, sometimes being in Colorado. And some days it would just we're like, man, the mountains look really big and really close today. And other days they just, or we would drive into town further away from the mountains, but they would look bigger than from our property. And it just goes to show that, yeah, it probably, because of the different conditions on the different days, they probably did look different day to day. And
absolutely,
you're not crazy.
And yeah, we just want to shout out some other channels as well. I mean, there's so many channels to go through, and we'll check our description and in our videos, and we'll talk about more in the future, because I think there's so many people out making just a lot of contributions that go unnoticed, making observations of their own, and we could collect all that data and, like I was saying last night, form a working model eventually. But Dr. John D, this video, and I couldn't find exactly the video I was looking for, but just his channel in general. But he was talking about all this years ago. Great channel that we'd recommend for sure. Just some of the clips from his video. Sorry for the delay, guys. It's a little slow right now.
Looking at
nice. Flatter-day Saints send me links. Yeah, and Flatter-day Saints, check out all the links in the description of our videos, and maybe I'll link some before we leave tonight. It's going pretty slow.
Try refreshing just that one.
Okay. Maybe too many tabs.
Oh, yeah. And again, it's my laptop that's not the greatest.
Okay, but yeah, check out Dr. John D, guys. Life is Short, The Plain Truth, Wide Awake, BMLSB, Pablosdog, James Mann, so many channels. Taboo Conspiracy.
Which one's this one? Oh, yeah.
Yeah, this is Dr. John D. Just a long time ago talking about refraction, upward refraction, the temperature gradient that I'm kind of talking about now. And I hadn't seen any of this at the time. Go back, and he had so much of it here. It's just a really good video right here. And like we said, life is short. In terms of vision, something that we don't really go into too much. We just talk about the atmosphere that kind of aids the optical effects and makes objects disappear faster in certain conditions.
They do all go together.
Mm-hmm. Yeah, this is excellent video here. Just want to check out. That's in our description. The channel's in our description. And is that all that we were going to cover this time? Oh, platform grace, not Gil. That's plain truth. Yeah, and we were also going to talk a little bit about Taboo's laser test, which I think we'll get into next time. We're already over an hour. And maybe it's Bonneville salt flat observation. But yeah, I think that's about where we'll leave it tonight.
Well, maybe if there's any,
we'll look at some questions, actually. Yeah, if you guys have any more questions or you have any more
we could
thoughts,
be done sharing stuff and just answer if there's
we'll be done sharing, and we'll answer any questions or thoughts.
Take suggestions
for future observations. That's frozen up. Oh, there it goes. How's it going, Gleam? Happy New Year. Bad Fish Bear, how's it going?
Yep, it's around doggy dinner time for some people.
Yaz Will Soaring, how's it going? John Watson, everyone in the chat, guys. Thanks for being here. No Fanfare, awesome channel as well. How's it going, No Fanfare? Has some really cool observations from some years back.
Yeah, we'll go back through. We'll read the chats.
We'll read through all that.
Make sure.
Any suggestions you guys sent, we'll look into all that.
And maybe we'll also get better about scheduling and giving, a heads up about we're going to go live or do have somebody on or open some conversation or whatever.
Yeah, we're really looking forward to having an open panel in the future and having a lot of you guys on. We've listened to a lot of you guys speak on other platforms, and we're interested to talk to a lot of you, all of you. So,
yeah.
So yeah, guys, any other thoughts or questions for us before we wrap this up?
The hour did go by fast.
That did go by really fast, yeah.
It's like we covered a lot of ground and said, maybe clarified some things if, just kind of overview, but at the same time, there's still so much we could talk about.
Oh yeah, we just barely scratched the surface.
It's a lot easier to do it like this, just kind of.
All right. Yeah. Thanks a lot, Bad Fish Bear. BMLSB. Thanks to everyone for stopping by, guys. We're going to go ahead and wrap it up, and we're going to stream again soon, and we'll have some more topics to go over. and email us. We can leave the email in the chat again, and feel free to email us with any suggestions or ideas, and we'll talk again soon.
Oh, is this still?
Oh yeah, there you go. That's awesome, Brian. I appreciate that, man. I want to talk to you sometime too. I've heard you before on other shows as well, so you can come on anytime, and when we have open panel, we'll discuss various topics.
All right, it's on here on mine.
Okay, I think it's just kind of delayed over here. Okay, all right, guys. Thanks for stopping by, and we'll see you soon.
Bye.